Okay, we're going to continue in part 2 to explore what the slope is telling us about the function. So here we are back at our graph of f of x, the cubic function, and in blue you see the derivative graph drawn, the slope function graph. And we looked at the fact that when the derivative is positive, the function is increasing. When the derivative is negative, the function is decreasing. Okay, in part C, when the derivative of the function changes sign, so that means f prime of x changes sign, and that could be either from positive to negative or from negative positive to negative, or from negative to positive. So where does that happen on our graph? Starting on the left, we start out with a positive derivative, then 0, then negative. So our function, what has happened to our function when our derivative has gone from positive to 0 to negative? So changing sign. Well, our function was increasing, then it stopped increasing and became decreasing. Okay, so our function has a turning point. That's what we call that, a turning point. All right, so we've gone up, we've stopped, we've gone down, we've turned, essentially. Okay, let's keep looking. Here we have a derivative that's negative, then 0, then positive. So negative, 0, positive. Okay, what's happened on my function? The function was decreasing, came to a stop, and then became increasing. Again, that's a turning point. So I'm just going to mark this as point A and point B. Okay, so the function has a turning point at point A and point B. Okay, when the derivative function f prime of x has a turning point. Okay, so what are we talking about here? When the derivative function f prime has a turning point. Okay, now we're talking about the f prime of x graph. Does this graph have a turning point? Notice the turning points happen at either a maximum or a minimum. Okay, so point A was a max, it was a high point on our graph, and point B was a min. It's a low point on our graph. Okay, so does the derivative function, f prime of x, have a maximum or a minimum? Well, here we go on our graph. The blue derivative graph, the graph is decreasing. Somewhere in here, maybe about at 1.5, the graph changes directions from going down to going up. Okay, the question is, what's happening on our function when that happens? Okay, taking a look, here our function, I'm going to highlight this here in green. Our function is called concave down, kind of like a frown, concave down. And in this next section, the graph is concave up, like a cup. Okay? So when the derivative function has a turning point, f of x changes concavity. And in this example, f of x changes from concave down to concave up. And I'll say at point C. All right. Okay. Let's continue on to number 5. The graph of the function f of x is shown at the right. So here we have this f of x function. Looks like it's increasing, decreasing, increasing, decreasing. All right, we are supposed to fill in the table with the values of the slope. At 1, 2, 3, 4, 5, and 6. So when x equals 1, be careful, the grid is, every 2 units on the grid is 1. So at 1, and we're going to approximate this, I'm going to say that at 1, my slope is 0. Okay, what's happening at 2? Draw a tangent line to the curve and estimate its slope. I'm going to say -1. Okay, at 3, what is the slope at 3? My tangent line might not be perfect, but maybe it's 1.5. You could say it's 1. I don't know. All right, at 4, what's happening at 4? Okay, that's still a positive slope. Again, didn't draw that very well. You could probably draw that better. But at 4, maybe the slope is, 0.75. At 5, what's happening? That one's not bad. I'm going to say that slope's a -1. And at 6, it looks like we're getting really steep. I'm going to say that slope is -3. All right, now I'm going to highlight a couple other slopes in here. Okay, we did the slope at 1, and we said that was about 0. Somewhere in here, between 2 and 3, there is a slope of 0. Okay, I'm going to say that's at about 2.4. So I'm just going to put that in my table. 2.4, slope of 0. Okay, over here between 4 and 5, again, we have a slope that's close to 0. You might call it 4.5, you might call it 4.4, whatever you call it, slope of 0. Okay, it says sketch a graph of f prime of x and do this on the grid. So I like to start and put the zeros on the graph first. Again, those are kind of my anchor points. Then I like to say, okay, what is the slope between 0 and 1? Well, it's going to be positive, big here, getting smaller here. So I have to start big, positive, and come down to the 0. what's happening between 1 and 2.4? The slopes are negative. Okay, somewhere in here, maybe it's about in the middle, I'm going to have the biggest negative slope. Okay, so maybe at like 1.5, the slope is as low as it's going to go. And then the slope stays negative, but it's got to go back to 0. So 0 slope, negative small, negative bigger, negative bigger. Then slopes are decreasing. No, I lied. Slopes are increasing, right? They're negative big, then negative smaller, then negative, half, then 0. So slopes are increasing. So the curve is going back towards 0. All right, between 2.4 and 4.4. Okay, the slopes are small positive, getting bigger positive. Somewhere in between, there might be the biggest positive slope you can have. All right, so slopes are small, getting bigger, positive. Then they reach a place where they are the biggest positive slope they can be. Slopes are still positive, but getting smaller positive. So getting closer to 0. Okay, what happens beyond 4.5? Slopes are negative and small, negative bigger, 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 bigger. Okay, so this red graph would be the graph of my derivative function, when the original graph was the graph of my function. Okay, sketch a graph, do this on the grid. Check. All right, number 6, for each of the following, sketch a graph of the derivative function on the axes with the function. Use a colored pencil. Okay, part A, we have a linear function. Lines have a constant slope. It appears that this slope is negative a half. So all we have to do is draw a straight horizontal line at negative a half. All right, and that's going to be our derivative. F prime equals negative a half. Okay, second graph is a parabola. All right, what's my strategy? I like to start where is the slope equal to 0. I'm going to say the slope is 0 at negative 1. What are the slopes from negative 4 to negative 1? They're positive big, positive smaller, getting closer to 0. What are the slopes after negative 1? Negative small, negative bigger, negative even bigger. Okay, I haven't drawn it, with any accuracy with the grid. I'm just saying I've got positive big slopes getting closer to 0. Then I've got slopes that are close to 0 but negative and getting bigger negative. Okay. Part C. Okay, draw those horizontal tangents first. Mark those points on the x-axis. We're indicating that the slope of the function is 0 at those maxes and mins. What are the slopes from negative 4 to negative 2? They are negative. Negative big, negative small. Okay, so we've got to be below the x-axis coming to that 0. What are the slopes between negative 2 and 0? Well, they're positive small, somewhere in between, right? Maybe at negative 1, they're the biggest they can be, and then they're going to get positive small again, and back to 0. Okay, between 0 and 2, it kind of does the same thing, but in reverse. We've got negative slopes, right? Negative small, negative big, negative small, 0.